How are you doing after after lunch and one more talk? Okay, I hope you're still awake. So my name is Arnon Axelrod. I work for Sela Group as a consultant and group manager of test automation. I also expert in clean code refactoring, unit tests, and all this related stuff. About a year ago, I wrote or published this book, Complete Guide to Test Automation. And actually, before I was a test automation expert, I was a developer and an architect for many, many years, since '95. I got into test automation from unit testing, TDD, and all of these things. And in recent years, I work more with test automation developers and testers. But today I wanted to talk again to developers about test automation. By the way, what I found very interesting about test automation is that it relates to almost all other aspects in the development life cycle, from the architecture to the working practices, documentation, of course, testing and quality, and even things like the business culture, the business structure, and the business structure. One thing I want to get right is many people, when they talk about testing and about quality, they use these terms almost synonymously. Most QA departments are mostly do testing. And the thing is that testing has not so much to do with quality as what you are doing as developers. I think that you are, as developers, has much more effect on the quality of the product than the testers. And we'll talk about how test automation is related both to testing, but also how it really affects quality. Also, one very common conception, I wouldn't call it a misconception because it's not, there's no right and wrong here, but a very common conception is that developers write only unit tests, and they are the owners of the unit tests, and the testers or test automation developers only write their system tests, their end-to-end tests, Selenium or whatever tool they're using. And these are treated like two separate things. Just one more thing to set the scope for this discussion. Testing and test automation specifically covers many different things, but in this talk I'm going to focus mainly on functional tests, both unit tests and other kinds of like system tests and integration, etc. All of these are kinds of functional tests. They verify that the application behaves as we expect it to. So let's start by making a comparison between, again, these conceptions or misconceptions regarding unit tests vs system tests. So first of all, the purpose. Most of us believe that unit tests should verify the implementation of each function or method or class, while the purpose of system test is to find more bugs, is to help the testers find more bugs. This is what they usually do. The test automation helps them. This is the first conception or misconception, as you like. We'll talk about all these things later, and we'll suggest a different point of view to each of them. Regarding the ownership, I also already mentioned it, that it's a custom that developers are the owners of the unit tests, and test automation developers, which are different role, are the owners of the system test. It means that they write, they maintain, and they investigate the failures in these tests. The next thing is, when do we run these tests? So typically, unit tests run after each check-in. Even on the developer's machine, developers run the tests before they checking in their code. But usually, system tests run only at the nightly build, only nightly, sometimes even just before release or on demand. What about the scope of what we're testing? So this is almost by definition. A unit test is a single class or single function, and in system test we test the entire system, like a real user. In unit tests, in order to be able to test single functions or classes, we typically use mocks to isolate the system under test, our class or function under test from the rest of the world. We use mocks. Well, in system test, we typically use the entire environment, a full environment, usually the test environment, which is separated from the production environment, but still, it's a complete environment. What about data? How is it different? So in unit test, we typically use fake data. We create the data only for the purpose of the test. And mostly in system tests, we use real data. Again, all of these things are the common conceptions, okay? I don't say right now whether it's right or wrong or if it's the best way, just what most people, I believe, as far as I see, what they think. Regarding stability, so unit tests are very stable. There are much less flaky tests in unit tests, and system tests are much more flaky. They are much less stable. And of course, that unit tests are very fast, and system tests are very slow. And it's very easy to investigate failures in unit tests, and it's very hard to investigate failures in system tests. Last thing is, when do we write these tests? So unit test, we write as close as possible to the development, which even most of us know we should try to do TDD and write them before. With system tests, it's almost never the case. Usually they typically say that we cannot start writing automated tests before the feature is working. Okay, so these separations. Some of them has real reasons, some of them less, but this is what most people believe. Another conception or sort of conception is the test pyramid. So it's very common to hear that we must have, like, let's say 70% of the test should be unit test, 20% should be integration, and 10% should be end-to-end, or something along these lines. So this is a very common belief that we'll also return to in the end, whether it's true or not. But by the way, in the middle here we have integration, which we didn't talk about until now. We just talked about unit and end-to-end or system tests. Now there's this integration in the middle. But in my opinion, we should not talk about unit integration and end-to-end. Instead, I use a different term, which I called a test scope. or sometimes it's called the test bed, which is more related to electrical engineering. People coming from this background may be familiar with this term, but I use the term Testscope in the software domain. So in order to understand what a Testscope is, let's first understand what is an automated test. And in order to understand what's an automated test, we need to understand what's a system under test, what's a component, what's a computer system. So everyone knows that a computer system is something that gets some input, does some processing, and gets some output. This is very trivial. And an automated test is like another piece of software that injects input to the system under test and verifies the output. It compares the output with some expected result, expected output, and if these results match, then the test passes. If not, the test fails. Now, what it has to do with Testscope? So, in most real systems are much more complicated than these rectangles that we saw before. Typically, they are made of many different component services, third-party services, very complex architectures. And what are the inputs and the outputs in such a system? It's very hard to define what are the inputs and the outputs in most systems. But when we come to define a test, we must define the boundaries of our system under test, which is the test scope. So we should define, these are the components we want to test. All the rest, for example, may be third-party or things that we trust more, or maybe we'll test them in different kind of tests. And in some scenarios, we use this scope, and for this scope, it's easier to determine what are the inputs and what are the outputs that we expect. Let's see more concrete and simpler examples. So we can treat the entire system as our system under test. This is the classical end-to-end or system test. If we're, again, talking about unit tests, so these are very small scoped components that we test, typically in the business logic or some other logic. We can have many different other scopes. We can test only the client while creating a mock or a simulator for the server. We can do the opposite, testing only the server. This is very popular today. Most people call it API testing. Then we only test the server side without the client side. We can test the server side, the backend, without a real database. We can create a mock for the database, for example. So there are many different kinds. Another kind of test scope that we can create, in some situations, we have some limitations or problems interacting with the application directly from the UI, then we interact with it like beneath the UI, beneath the skin of the UI, but it's still almost like end-to-end. And we can go as far as we want and as creatively as we need to in order to test what we need. For example, we can take all the components which has some logic that we want to that we need in our test, and mock everything else. We can mock the communication between the client and the server and do all of everything in the same process, given given that they're using the same technology, or we can bridge somehow these gaps, and mock everything else. In general, I invite you to open your own minds and think about your applications and the architecture of your applications and what you want to test, and decide for your own what is the correct test scope for each test. So instead of have unit test and system test and maybe integration in the middle, for everything you want to test, ask yourself what is the right test scope for this particular problem. But let's go back even one step back. What's the purpose of test automation? Why do we need it? So, do we need test automation in order to help us find bugs? Some people believe that this is what test automation is all about. In my opinion, people like manual testers are much better, in most cases, in finding bugs than machines, than test automation. So, what else? What's the purpose of test automation then? So, in my opinion, test automation is more about preventing defects, preventing bugs, rather than finding them. And in order to understand how test automation can help us prevent bugs, it's not directly. It's not. They do not prevent the bugs by themselves, but they help us do other things that consequently prevent bugs. So one of the most the major reasons for bugs is problems in the code structure. When the code is not written in a clean code way, or the architecture is not optimized. And typically when we start coding, we try to design the best architecture we can, and we do our best, but over time, because we're under pressure to deliver fast, and because requirements change, right? We want to be agile, we want to be able to respond to changing requirements, but nobody gives us enough time to handle the technical debt. Are you agree with me? Okay, so over time, typically the structure of the code deteriorates. But in my opinion, one of the reasons, or which also are the solution to this problem, is a skill that unfortunately not too many developers have enough of, and this is the skill of refactoring. And I consider it a skill because it's something that you should practice. And also, as far as I encountered, at least, most developers don't understand this term as exactly right. Refactoring is not about taking a week or two or whatever and redesigning some part of the application in which, during which the code is broken, nothing compiles, or nothing, the tests are broken and nothing runs. This is not true refactoring. Refactoring is a skill in which you take a series of very small steps. During each one, after each small step, everything works, all the test passes, everything works, everything compiles. I'll just read the lower quote from the book Refactoring of Martin Fowler's. If someone said their code was broken for a couple of days while they were refactoring, you can be pretty sure that they were not refactoring. Okay? So refactoring is a skill that you must master and practice in order to do very small changes. And this series of small changes can bring you to a code which can be very different and have very different design and very different architecture even than the original one. And one of the things that we want to get to when we have good design or simple design, we have we want to be our code to be very loosely coupled, so we can be sure that loosely coupled, it means that we have as many interdependencies as possible between different components. And this ensures that if we make changes in one component or one piece of code, there's much smaller chances that it will break something in a different part of the application. Other characteristics of simple design is that we have no duplication in the code. And it's modular. There are others. I won't get very deep into these things. But also, when we have these loosely coupled and modular design, it has two more benefits. One, it helps us as developers implement new features faster, and as an organization, it helps us deliver new features faster to our customers. And the second one is that we can have smaller, faster, and more reliable tests, and rely more on unit tests, for example, or smaller scope tests rather than on system tests. One problem that often happens when you try to do unit tests, to invest in unit tests when the architecture is not optimal and the design is too complex, is that these unit tests, instead of helping you improve the design of the code, they only keep the it ties you to the current architecture, and it makes you even more difficult to refactor. So sometimes it's better not to have unit tests if the design for a bad design, rather than have more unit tests in a bad design. One of the there's a set of rules which I like very much, and I think it's something that all developers should know and should be taught at every programming school, but unfortunately they are not very well known. I guess that many of you are familiar with the solid principles, by the way. Is it true? Yeah, okay. But how many of you are familiar with the 4 rules of simple design of Beck? None. I don't know why, but I think they are much more powerful. These 4 rules are, from one hand, are very simple themselves and much simpler to understand and to remember than the solid principles, by the way. The one thing that maybe is more special about these rules rather than the solid principles is that these rules are in priority order. You must adhere to the first rule before you go to the second and to the third and so on. So the first rule is that the code should pass all the tests. The tests should all pass, even manual tests if you have. It doesn't matter, the code should still do what it needs to. Oh, by the way, Beck is the author of the book Test-Driven Development by Example, is considered like the father of TDD. So when he says passes all the tests, he presumes that you have all the tests in place. The second rule is that the code should reveal the intention. When you read the code, it's like about readability of the code. But it doesn't just say the code should be readable. He says that the code should reveal the intent. It should reveal what the code should do, what the intention of the code, and not how it should do it. And the third one, which I think is the most important in terms of the design and the architecture, is no duplication. Now, duplication can come in many different flavors, if you want, or kinds. It can be like complete functions or classes or parts of the function that is duplicated in many things that you can see, like someone did a copy-paste. This is a very classical example, but it can even be things like magic string or magic number that repeats itself a few times in the code in different parts of the system, but relates to the same thing. If you change in one place, you must change in the others. Okay, this is also duplication. But it also, if you have duplication in the tests and between the test and the code of the system under test, this is also duplication, and it usually indicates coupling between between your code and your user's code, or your client's code. And the last rule is fewer elements as possible, sometimes called YAGNI, you ain't gonna need it. By the way, the no duplication sometimes is referred to as dry, do not repeat yourself. So after everything is, after we adhere to the first 3 rules, we also don't need any redundant code that is just for future purposes. So these are the 4 rules of simple design. And the purpose, if I get back to the purpose of test automation and how it helps you prevent defects, then in order to do refactoring, you must have good suite of good tests that ensures that you don't break anything while you do refactoring. And you do refactoring in order to improve your internal design and the design of your code, which help you prevent defects. So test automation on itself does not prevent defects, but it helps you refactor, and which helps you have better structure code, and that prevents defects. So let's talk a little bit about how do we design the tests properly, whether it's unit or any other kind of functional tests. So in my opinion, all of the functional tests should always describe or test observable behavior. So you may think that it means that everything should be tested through the UI. It doesn't mean it. Why? For example, if we have a function that calculates tax for something, for example, then eventually the user should see the result in the UI. But if the calculation won't be correct, the user will notice it, even if we test it in the unit level, but the user will see it eventually in the UI. So for this example of a tax calculation function, we can have a unit test to test this function. But if the function only takes some data from one data structure and converts it to another data structure that the user doesn't care about, then this is probably not a good test. And this is not something that you should write a unit test for. We only should think about the observable behavior. There are few concepts of how to structure the tests. One that is very familiar is the arrange, act, assert, which states that we first this should be in each and every test, right? We should first arrange the preconditions for what we want to test. Then we should perform the action that we want to test, and eventually we want to assert that the result that we got is the expected result. Another paradigm which is very similar, it's almost the same, just different terminology, is the give and when then terminology, which It's more like a story that you can read. Given we have these preconditions, when we do the operations that we want to test, then we expect some result. Now, these are fine concepts. I like a little bit more generic way to think about it. And I say that every test you should think of as a claim, like something that you want to prove or disprove. Whether this functionality, does the system perform this functionality or not? And this claim, I typically use it as the name of the test itself. It can be long. I don't mind because I don't have anywhere else in the code calling these test methods. So it may be long, but it's very readable and it reveals the intent, by the way. And the body of the test method is the experiment. It's what I need to do in order to prove or disprove this claim. This is how I think about writing tests, whether it's any kind of functional test. Let's see an example. So here we have an example. Adding product with promotion gives discount. The first two lines are just defining the constants. So we create a product for iPhone in the price given in the beginning, $1,200. Then we create a promotion on this product that gives a discount of $150. Then we create a shopping cart and add this iPhone to the shopping cart. And eventually we assert, I'll point to this side now, we assert that the total is the price minus the discount, so that we got what we expected. By the way, what kind of test is this? You cannot tell. And it doesn't interesting. It's not interesting. It can be a unit test, and it can be a system test. It all depends on our architecture and how we organize the test and our architecture. But nonetheless, the test should be written like this, even if there are unit tests and even if there are system tests. It doesn't matter. Let's talk a little bit about best practices. So always try to keep it simple. The test should be simple, should not try to test a lot of things together, just one thing at a time. It should be reliable. Whether it's a unit or system test, we should think about how the test will be reliable. In order to be reliable, we need to isolate possible interactions that this test may have with other tests that run before or after, or maybe in parallel. We want to define the expected result in a very deterministic way. And typically, in order to define the expected result in a deterministic way, we need to control all the relevant inputs to the system. So we have to think what can affect this result and control it in the test, whether using in-memory mocks or simulating third-party services, for example. We should also not assume anything about the data in the database that the test didn't create. Maybe someone will play with this data, or at some point will replace the entire database with data from another customer or whatever. We don't want the test to be influenced by this. And mock anything that you cannot control. Next, we must ensure that our tests are very easy to maintain. They are readable, reveals the intent, as we said, have no duplication. And notice that in test automation, we have almost 100% code coverage for the tests themselves. Okay, the test may not cover the 100% of the application, but the code of the tests are typically very close to 100%. So we can refactor very easily, and we can at least practice refactoring in at the test. Another technique that I think that it's a broader technique. It's not something that just the developers do themselves, but I think that is very, very important and very, very effective is ATDD, Acceptance Test-Driven Development. And what Acceptance Test-Driven Development starts with a user story. And for me, a user story is not like a small specification that the product owner wrote and maybe split it to smaller user stories. But in my opinion, the product owner should only come up with the problem definition as a role in order to, but without the I want and this is the solution. I want only, the user story should only describe the problem or the KPI that we want to move and not the solution. So this is the first step in this process. The product owner defines the problem as a user story. And then he calls the team, or at least some representatives from the team, and they collaborate in order to find the simplest solution for this problem. Now, the simplest solution may not be the best solution, but at least it should be something that we can deliver very quickly to our customer and get feedback, and we'll see if it's good enough or not. Then the team should collaborate in order to define and agree on the acceptance criteria for this solution. Now, the acceptance criteria is in fact an example of how the user will use this solution. So it's like the user will do A, B, C, and we expect to show him some results, some output that he hadn't had before. So let's say we expect X. So we do A, B, C, and we expect X. This thing is actually like it's a test, right? So, by the way, this acceptance criteria also helps understand that everyone in the room understands the same thing, and that what is the scope of the user story, that we don't intend to develop more things and more complicated things. These acceptance criteria, this is what we're going to develop in this sprint or in this user story, and that's it, okay? So we define this acceptance criteria as a test, and then we can implement this test as an automated test that, of course, will fail at first because we haven't yet developed the code that will make it work. So then the developer implements the code and refactor continuously. It's not something that you need to have some dedicated time to. In fact, in most cases, you start by refactoring the current code in order to make implementing the new feature easier. So you keep the code in clean shape all the time. And of course, that at the end of this stage, the automated test should pass and all other tests should pass. And then we know that we have no regression. Eventually, or almost eventually, we need to have some exploratory testing, some manual tests, because sometimes we cannot anticipate what may happen before we see the solution in front of our eyes. But pay attention that the scenario that we already defined in the acceptance criteria already works. So if we find some issues that are either very small and we can fix them quickly, or there are different scenarios that we should define as new user stories. And eventually, we deploy this solution to the customer as quickly as possible in order to get feedback. And the feedback may be that we need to improve it because we just selected the simplest solution, but it's the right direction. It may be that we need to, it's not good enough or it's not good at all. We need to find another solution. At least we learned something. And it can be, the feedback may be, okay, it's good enough for now, and we have other problems which are more important. So we didn't invest too much time in this feature. We only invested what we needed. Let's get back to this table of conceptions and misconceptions. I'll go through it very quickly because I don't have much time. So regarding the purpose, whether it's unit test or system test, the purpose of these tests is to verify the behavior in order to help us refactor, in order to help us have clean code and good design, which improves quality. Okay, this is the main purpose. About ownership, so all the team, in my opinion, should own all of the tests together. It shouldn't be this division. And all tests should run as soon as and often as possible. So naturally, slower tests may take longer cycles, but we don't have to run them nightly. We can run them if it takes 2 hours, then we can run them cyclic every 2 hours. The scope of the tests, unit tests are smaller, system tests are larger. This is by definition, but we use what we need according to the problem. In any case, we mock or use simulators for anything that we need in order to make the test stable. We typically should use fake data, whether it's for unit tests or for system tests. And we should invest in making or design the tests in such a way that there will be stable whatever kind of tests they are. Regarding speed, then unit tests are naturally very fast and system tests are naturally slower. There are a few things that you can do about it, but not much. Regarding failure investigation, then it's indeed very easy to investigate unit tests because they usually only test one method or class. But in the case of system tests, if it's not easy, you should make it easy. You should add more logs, screenshots, or whatever you need in order to make it easy to investigate these failures. And as we talked about the ATDD process, preferably all of the tests should be written before the fact and not after the fact. Let's get back to the pyramids. Oh no, these pyramids. This pyramid. So we already mentioned that it shouldn't be this dichotomic separation. It should be like more linear, if you like. But the question is whether we need a pyramid or maybe we need a rectangle or somewhere. I heard the diamond shape or many things. So in my opinion, you shouldn't be too concerned about this question. And you should do whatever kind of test you need according to the problem at hand. But if your design, if you really manage to keep your design very modular and very loosely coupled, then you'll end up naturally with many unit tests and less broader scopes tests. So if you do everything correctly, you should end up with the pyramid, but you should not try to strive to be at the pyramid just in order to be there, something like that. Okay, so summary. Test automation is not the concern only of the testers or of the QA team. It's your concern. It's you are as developer are responsible. You have the most control over the quality of the code you write, and quality comes from the design, and the design evolves from the test. Evolves using refactoring, and test automation enables this. And I think everyone should work in collaboration. The developers and the testers should collaborate about the test automation in order to improve both code reviews, design reviews, like work together as, and of course, help them investigate their failures and vice versa. And most of the best practices and principles for how to write tests apply from unit test to system test. It doesn't matter. It's more or less the same. Any questions?
Thank you very much. Just a question, what tool or what infrastructure would you use for load testing of a hybrid multi-component system with a back end and services and the front end, and why?
What kind of infrastructure are you talking about?
Azure services and some UIs, maybe some APIs, different APIs. How would you load test that, and with what tools? Maybe
load test?
Yeah, load test.
Ah, okay, load test. Okay, like I didn't speak about load test.
Yeah. I know.
Okay, as I said in the beginning, the scope of the talk was mainly functional tests. But load tests, I think that the most popular tool is what's its name? JMeter, exactly. Yeah, I think that this is the standard de facto, if you want, for load testing. There was very good tool in Visual Studio, but unfortunately in Visual Studio 2019, they declared that this will be the last version they support it. It's a little bit unfortunate because it was a good tool, but this is reality.
Thank you. Thanks for the presentation. Some question, do you have some recommendation or best practices for putting to testing flow, in these cases, for example, application performance testing, and in some piece, like resource consumption limitation testing, something like that?
Okay, so again, it's more about load testing. If you're talking about testing resource consumption, it's mainly a matter of load. You want to simulate many concurrent users or very intensive usage. So, as I said, JMeter is probably the best tool currently, or the most popular, at least.
So I try to define my question. In your practice, do you have some examples where developer can control in the first steps in the testing, it's happen or not happen, changes with like big changes in resource consumption. It's something not like APM tuning. It's about only big changes, some mistakes, for example. It is possible or in normal practice, or what do you think about that?
If I understand correctly your question, then you're asking whether it's possible to instead of have like big load testing, to have like small load testing for smaller components in order to know that they don't, that the resource consumption of this.
You're a developer. You change something in your code on small pieces, but after that, your code take 3 times more resources, and you didn't see it. And just go to other steps, yeah. And how control this exactly, or this is happen in from your experience?
In my opinion, you should do load testing, the regular load testing probably in most cases. It's a complete, it's an entire topic of in and of itself, the load testing. It's really a different way of. It's different. It's testing different thing, and it's the way you test it is different. I cannot get into into much details in few minutes. Sorry.
And the last question.
Regarding the communication between QA and developers, typically the work are strictly specified. I mean, the collaboration are really focused on some specific bugs and other stuff. So, are there any suggestions from your side to have the bigger vision from the team to collaborate on the, I don't know, bigger understanding of the architectural or other failures, because otherwise we will only understand that we need to fix some part of the system. Either we have, I don't know, 30 bugs from this part of the system, either developers will told us that it's slow.
Well, I think that the developers and the testers should work more collaboratively. Many companies today, I don't know how your company works, and if it's but many companies today are changing their organization structure from different sub-organizations for QA and for developers into like full stack teams that contain both developers and testers. I think it's a good thing, and I think that it should not stop there. They should work also collaboratively to share knowledge and to review each other's code and to talk about the architecture, to review the test. The developers should review the tests that the testers do, etc. Typically, it's a process that takes a long time. It doesn't happen overnight, but this should be the direction.
Okay, thank you. If there are more questions left, you can ask them in Speaker Lounge. Now let's thank our speaker for the lecture with applause.
Thank you very much.